This is an A-level mechanics question, which is vectors in mechanics, also known as constant acceleration in 2 dimensions. In this question, I and j are horizontal unit vectors due east and due north respectively, and the position vectors are given relative to the fixed point O. A particle P moves with constant acceleration. At time t equals 0, the particle is at O, the origin, and is moving with velocity 2I minus 3j meters per second. At t equals 2 seconds, P is at the point A with position vector 7I minus 10j meters. Part A showed that the magnitude of the acceleration of P is 2.5 meters per second squared. So this is a SUVAT question or RUVAT. Often with vectors we use R for displacement rather than S. You can use either. So I'll write SUVAT. I have the initial velocity because that's at time equals 0. So that's going to be 2I minus 3j. I have the position of the vector at 2 seconds. So when t is 2, I have this position r or s is equal to 7I minus 10j, and I want to find a, so I need to find a suitable equation, and I can use s is equal to ut plus half at squared. So again, we could use r there instead of s, but the working is going to be the same. So I'm going to work in columns. I just find that easier. So 7 minus 10 for s is equal to u. So that's 2 minus 3 times by t, which is 2, plus half a, the acceleration, times by t squared, which is going to be 2 squared or 4. So let's work from there, see what we have. So 7 minus 10 is equal to, times the u by 2, so we got 4 minus 6. And then what happens here is we're going to have half times by 4, so 2. So plus 2a. Let's rearrange. So we will move this vector over to the other side. So you've got 7 minus 10 minus 4 minus 6. That's going to equal to 2a. So let's work out 2a and then divide by 2. So 2a, so we've got 7 minus 4, which is 3. And then we've got negative 10 plus 6, which is going to be negative 4. So that gives us a is equal to 3 over 2 and minus 2. So what we're going to do now is to find the magnitude of a. So I'll do it up here, and that just means doing Pythagoras on our 3 over 2 and our negative 2. So let's see what that gives us. And that gives 5 over 2, which is equal to 2.5 meters per second squared as required. So always get to the form that they asked for, and they asked for 2.5 meters per second squared, not 5 over 2. At the instant when P leaves the point A, the acceleration of P changes so that P now moves with constant acceleration 4I plus 8.8j meters per second squared. At the instant when P reaches the point B, the direction of motion of P is northeast. Part B, find the time it takes for P to travel from A to B. Now I've got my results from part A. The acceleration is what I worked out at the time and you were given, and just sort of give you a rough idea of what's going on. So this is not to scale, this is not to say exactly how something is moving, but I'm going to label these points as O, A and B, so don't take this literally, but I do know that from O to A the time was 2 seconds, the acceleration was 3 over 2 minus 2, and the initial velocity u was 2 minus 3, just as column vectors. Now for the second part of this journey, we want to find the time it takes to go between A and B. We know this acceleration for the second part we've been given is 8.8, and I need to find the velocity here. So the velocity at this point A is going to be v using the values that I used in part A, and that v that I get from part A, so v from part A, not pat A, part A, that will be my u for part B. So this will equal my u basically for this part of the question, so for part B. And we're also told that when it gets to this point B, it's moving in a northeast direction. Okay, so as I said, don't take this literally, this diagram, because that's definitely not northeast. And when something's moving in a northeast direction, that basically means that the I part of the velocity, so the I part of v, is going to equal the j part of v, and that should be enough to help us work out what the time is. So let's start by working out what v is at point A by using the information we got from part A. So SUVAT, T was 2, so this is the first part of the journey, part A. A was this 3 over 2i minus 2j. U, that was 2i minus 3j, and v is what I'm trying to find. So the equation I'm going to be using is v is equal to u plus at. We'll substitute those values in, so v is going to equal u, so back to columns again, 2 minus 3, plus a, 3 over 2, times by minus 2, times by t, which is 2. So v is equal to 2 minus 3, and then plus, so 3 over 2 times by 2 is going to be 3, and 2 times by minus 2 is going to be minus 4. So from that we will get v is equal to 3 plus 2, which is 5, and then minus 3 minus 4, which is minus 7. So that is the velocity at this point, my u, for the second part of the journey. So now I'm going to do a second SUVAT, and this is for A to B, and I need to do a second SUVAT because the acceleration has changed. It's something different to what it was before. So T is what I need to find. The acceleration now is this 4i plus 8.8j. The initial velocity from A to B is this final velocity I worked out from O to A, which is 5 minus 7. So I'll write u as 5i minus 7j. And I know that v is what I need to find. I know it's traveling in this northeast direction, so I know that the I component and a j component of v are going to be equal. So I've got u, v, a and t again. So same equation, v is equal to u plus at. Let's plug that in. So v is going to equal to 5 minus 7, that's my u, plus this new acceleration for 8.8 times by t, what I need to find. Now this is where I use the northeast bit. Now the top row represents my I part, so let's highlight that, multiplied by t, and that's going to equal what I get from my j part, which is the bottom row here, and I can set those equal to each other and solve for t. So if I do that, I will have, in black pen, not yellow pen, 5 plus 4t, so that's what I get from the top row, that's my I part. It's going to equal to my j part, which is negative 7, plus 8.8t, and we just solve for t. So if I take 4t away from both sides, let's do that first. So we'll get 4.8t is equal to, and then I add 7 to both sides, so 4.8t is equal to 12. So t is going to be 12 divided by 4.8, which is 5/2, or 2.5. So it's going to take 2.5 seconds to move from A to B.